So we have a full Chrome here. Today we have all the new friends. Sam just joined us in this meeting, and
hello, Sam.
And,
hey.
And so Jim has been with us for a long time, and we have met before. And Yingxin, could you have a very short introduction to yourself?
Okay, so I'm working on Crimson Messenger part, and I'm from Intel.
And Ying has been did some very interesting profiling
Yeah.
work in last Cephalcon.
Yeah, that's distributed tracing. Cool. So that's very difficult to integrate with Ceph.
Dude.
And I think everyone knows them already. And let's start from myself. And last week I was working on. Actually, I was trying to break the big fat PR into smaller pieces so we can review it and merge it sooner. Also, I was trying to model the waiting list. There's like 7 or more waiting lists defined in PG and PG primary. It's documented in pg.h. You can see the line starting at 1.3.11, where we have to get where we queue the blocked requests and re-enqueue them once the precondition blocking them are fulfilled. I was trying to model them in a SeaStor way, and I will send out the PR to later on, and was also reading the snapshot snapsets and clone related code, trying to figure out what if we wanted to support snapshot and clone for the right request. And I think my next step is to benchmark the Crimson OSD with Riddle's CLI to send them with random read request after pre-populate the memory store with a classic OSD. And I think that's me. Jim, how's it going?
Sorry.
Pretty good.
Last week I fixed the Alhan bug when doing message compare. I found a data lock in async message. This happened between when message call and the dispatcher head or tail. It will if the dispatcher is the first, it will call the ready of the single message, and if the other thread call if we do connect to OSD and the message work will receive the server identify and will do learn ADDR. It will call a sync lock.
Mm-hmm.
But in a sync message ready function, it will submit a task and wait the task.
I think that's
So
what
this
the
will
worker thread do, right?
deadlock.
Okay.
Currently, I only modify the FIO plugin to make first do and dispatch head and then call to connect to OSD. I don't I to avoid this deadlock.
So
Maybe
you're
I
basically
think
talking about the bug in FIO, right?
no. I read the proper message client. I found that this also first call connect to OSD and then call and dispatch head. This still have a chance to deadlock. From the logic, there is no first or the second to call this function. You can first connect to OSD and then dispatch head. You can and dispatch head and then call connect to OSD or others.
Okay.
That's all.
Okay, thank you. So if I recall correctly, you were talking about an issue in FIO, and you are trying to rewrite the test client to do the performance test with multiple client driving the Crimson message. How is it going? Basically, the multiple connection test with Crimson Messenger.
I still doing this because this bug.
Okay.
If complete the all test, I think it will go on.
Okay. Okay. Thank you. Ridek, how's it going?
I'm reviewing. I'm getting through the PRs. I'm in the middle of the big one, the FSM one.
Okay. Actually, it's basically a trimmed down version of the original recovery system machine.
Yep.
And only try to implement what is needed by the system machine. Yeah. Thank you. Sam, did the Crimson OD compile for you?
Yep, there was a little test thing I fixed. I assume you probably already noticed and fixed it. But other than that, it compiled just fine. I was able to start a cluster and then start up the Crimson OSD. Sometimes it seg faults. It doesn't seem to want to peer on PGs where it is not the primary, but it is making progress. I figure I'll just start looking into that stuff.
Okay.
Unless there's something more useful. This is on your PR, so I don't know how much of this you've already fixed, but it was from what I pulled today.
So you are testing the big PR, right?
Yes. Well, I repulled it today. Did the name of the branch change?
No.
Okay, then it should be from a few hours ago, maybe 6 hours ago.
Okay, that should compile and work. Anyway, I will try on my end also.
Well, the test one was just that literally there was one test with a stub in dispatcher that just had a copy paste wrong. It was super minor. I just assumed that someone wasn't compiling the test. That's all. For the other one, it's just not always completing peering. Although I was running on Rex, so it could be that they have a lot of cores. So perhaps that's triggering some behavior that is unusual. Is it?
Yeah.
Does
yes,
it?
That's expected.
Sorry.
I also spotted that it does not complete the peering.
Okay, cool.
Also,
yeah.
2 out of 5 times, I'm still trying to stabilize the peering process to figure out what is missing in the when tracing from one state to another state. Probably I was missing something.
So are you trying to implement the whole peering state machine?
Not at this moment.
Okay.
I was just trying to get the PG activated, clean and active and clean.
Yeah.
But this is two-folded thing.
Yeah, no,
one
it's
thing
not
to get the
yeah, that seems like a good plan.
Yeah, just to try to reply manager with the correct state of a PG, and also trying to update PG with the correct acting set and upset to prepare for the right request. Otherwise, it only can serve the read request.
I mean, another strategy might be to just fake it, right? If Crimson OSD makefs worked, then you could just start 3 Crimson OSDs and just assume they're not going to crash. No, really. Like, if your goal is to test the I/O paths, that might be easier. Because faking peering is kind of a lot of work, and you don't. There's a lot of stuff that.
Another approach is to just start a single OSD and set
that would
the
also work.
size to 1.
Yeah, that would also actually, for benchmarking purposes, that's actually kind of ideal, right?
Yeah.
You get 2 network hops, which is enough to get at least some exposure to the network pathways, and you get thread handoffs between the message bit that pulls it off the wire and the PG that needs to service it, so you get that behavior too. That should be probably enough to, well, keep a bunch of people busy with benchmarking, honestly.
Yes. That's also match our goal for an apple-to-apple comparison between classic OSD and
that's true.
OSD.
Because that would be pretty comparable.
Yeah, and but ideally I really want to experiment with the peering to see what could be sitting in the right path and what problem we could be facing in the midterm. That's why I want to try out
fair enough.
to implement the state machine thing. But we can get away from it with a size equals 1 and or just set up 3 Crimson OSD to fix the PG state.
The thing is, it's not immediately obvious to me that the existing PG peering implementation is bad. Just putting that out there. For the most part, once peering is over, it's just a set of Booleans in memory. Peering doesn't actually impact the hot paths, which is not to say that it isn't a waste of memory. It is that. But I don't know. I think I need to look into whether there's a way to write code that can work in both. 2 copies of peering would be really bad. That would be a nightmare.
Yeah. I think the most interesting is the IO path. Probably can leave the peering as it is, but if we can see any chance to simplify it, that would be great.
Well, I think what I'm saying is we want to limit the amount of, well, I don't know. My instinct is that I would want to limit the amount of fake peering I spent time on, unless that was the plan going forward. If the plan is actually to just have 2 copies, then might as well go for it, right? But otherwise, the size equals 1 thing allows you to get a lot of bang for your buck time-wise without having to invest in what hopefully will not, well, I don't know. I don't know. I need to look at it more.
Okay. And Yingxing, how's it going?
The V2 Lucy connection is, I think it is working now, and I also changed the unit test to test against V2 protocol, and it is working. So I think it is almost done, but I'm still looking at Redux pre-auth patch and trying to modify. Hello?
Oh, sorry, I forgot to unmute myself. My question was, is the authentication and encryption feature optional in V2 implementation? Put it another way,
Yeah.
Can we test your V2 implementation at the status at the currently?
No,
can we test it now?
encryption and decryption is not implemented. We are the current test only use the simplest way with authentication is none and with no encryption and decryption, and those features are not implemented. I just want to implement. I just want to try to make it work, and so we can start performance comparison. So we can left them in the middle.
My question was, can we test? Can we connect to the cluster with your V2 implementation without the encryption and authentication?
I didn't try to join the messenger to the cluster, but I tried to connect the Crimson Messenger with async messenger. It is okay.
Using the V2 protocol.
Yep, it should be fine, even because the encryption stuff is made experimental. It's not for production. It must the cluster must be able to operate without it.
Okay, if you, I think to ready the V2 implementation, we also need to support from the Monk client, right? So shall I start working on it? And is your implementation ready for the integration with the updated Monk client?
The interfaces are implemented. Like the V2 protocol. The most of the structures are implemented, but it cannot be running because it is not it's just not integrated with the current implementations. It's just if you look at current code, if it just assumes that the encryption and decryption is disabled, and if it is enabled, it just return. It just will break, just assert false.
But I was talking about the authentication.
Authentication, I don't know if the encryption and decryption is required for monitor. Can it be disabled?
I have no idea, but I think I'm trying to do the groundwork on the Monk client side to ready the V2 implementation. That's
okay.
I was why I was asking.
Authentication and encryption should be independent. Authentication long predates encryption and Ceph Messenger, if I understood that correctly.
Okay. Yeah, that's correct. First,
it's totally different. Yeah.
Sure.
So can we set authentication with none with the monitors?
Authentication, we can use the non-authentication. Yes.
Then it can work.
Okay. Anyway. So is your change ready for a review?
I will rebase the Redux pre-auth implementations to my current PR because it is based on the old master. I'm still looking at his PR. If I'm correct, the pre-auth is to sign the handshake buffers and to compare if there's some,
exactly. That's the entire idea. We are calculating a signature of the traffic we exchange during the negotiation.
Yeah, so that's also my understanding, and I will
there is just
apply
another stage between the auth done and client and server idents.
Yeah, so I will implement it with my PR, and then we can try to merge it.
Okay.
But all the functionality is working with the unit test.
Excellent. Do you take put more thought on regarding to the memory alignment, namely how is there any chance we can plug in this customized allocator into SeaStor?
I think we can, because if you look at the socket implementation, there's a consume function, and it can be assigned with our custom buffer. So with the assign, with the consume feature, I think we can create our own aligned buffer and fill the temporary buffer, the content of the temporary buffer, retrieve from SeaStor to that aligned buffer, and then return the aligned buffer to the caller.
So if that's true, we don't need to fork SeaStor for our V2 feature.
I think so, but I
feature.
didn't try it.
Okay,
yeah, I think we can return the aligned buffer using the consume method of SeaStor.
Okay, could you drop in mail pointing to line or the function signature so I can take a look into the details to make sure it works. Thank you.
Sure.
I think that's all. And any questions? Okay. Talk to you later. See you next week. Bye.
See you.
See you. Bye.
Bye-bye.